As we continue our discussion of trigonometry and the use of the unit circle, we're going to talk about another way to measure angles, and they are called radians. Now you have to think about measuring length. We talk about measuring in inches or centimeters or feet or meters or yards. When we talk angles, we're used to talking about degrees, but radians would be another way to measure. Now the definition of radian is the measure of a central angle that intercepts an arc with length equal to the radius of the circle. So I drew a picture up here. Here's my angle, and they're saying that this angle and this length are going to be the same based on the radius. Now for our unit circle, which has a radius of 1, since this radius is 1, whatever this angle is the same as this intercepted arc. So for instance, if I had something that was a certain angle, let's say pi degrees, this arc would also be pi radians. Now, let's talk about the ratio we're dealing with here. 360 degrees, once around the circle, is the same as 2 pi radians. So we should probably mark that on our unit circle, and we're going to mark all the other ones as well. So if you want to take some time and pause the video, you can convert them all. Here's the two conversion formulas, okay? And it's all based off of this ratio. So if I have degrees, like my unit circle, and I want to convert it to radians, I take whatever the degree measure is and multiply by pi over 180. Now we don't put pi into our calculator, we don't round pi, we leave pi in our answer. So as you go around your unit circle, you're going to have 0 pi, and you might have pi over 6, and pi over 4, and pi over 3, and pi over 2, and 3 pi over 2, and things like that. Leave pi in your answers. Now, if they give you something that's already in radians, and you want to convert it back to degrees, something we're more comfortable with, you take the radian measure and multiply by 180, and then divide it by pi, and this time we actually divide by pi to turn them back into an exact degree answer. So we're going to practice on a couple. This might help you fill out your unit circle as well. So if I have 150 degrees, I'm going to take that measure and multiply by pi over 180. So I know I'm going to have pi in my answer. And I have 150 over 180. I should reduce that. They both have a 30, so I get 5 pi over 6, or 5/6 pi. 225 degrees, again, you multiply by pi over 180. This is a good answer, but again, we want to reduce these. We want to get them in simplest form, so we find out what they have in common. They both have, okay, I can divide them by 45. Reduce them as much as you can. Here we have one that's already in radians, so I'm going to use the other one. I'm going to convert it back to degrees, so I'm going to multiply it by 180 over pi, and you can see how the pi's are going to cancel each other. I get 180 divided by 2, which is 90 degrees. So I have a few to add to my unit circle. 90 degrees is pi over 2, 225 is 5 pi over 4, 150 is 5 pi over 6, or 5/6 pi. Now if you do a search for any kind of unit circle, you're going to find both the radian measure and the degree measure on there. If you get one that's not on your unit circle, just run it through that formula. Take the degree measure, multiply it by pi divided by 180. The pi can go out front or the pi can go on top, it doesn't matter. And again, we should always try to reduce these. So if I reduce this down, I get 3 pi over 20. Okay, looks like they have a 9 I can take out. If they ask for a rounded answer, which we don't use a lot, but once in a while we will, just go ahead and multiply that out. Take 3 times pi, which should be built into your calculator, divide that by 20. Now the nice thing about this is once we have all of these radian measures on our unit circle, we can answer these same basic questions. Now if I don't have them on there yet, I might have to convert them. So I could take pi over 4, multiply by 180 over pi and reduce. But pi over 4 is a 45 degree angle. I look at my unit circle, They go to 45 degrees. 45 degrees, the cosine there doesn't change. The sine there, the same thing that I already have on my unit circle. 7 pi over 6, that one's a little strange. You might not recognize that one as well. It should be up in your first quadrant or second quadrant, I believe. No, excuse me, it's down in your third quadrant. 7 pi over 6. If I look at the cosine, I get negative square root of 3 over 2. If I look at the sine, I get negative 1/2. So we really need to get that unit circle with the radian measures and the degree measures so we can answer questions like these. The last thing we're going to talk about, since radians can be the angle or they can be the arc, we need a formula to help us find an arc. Now, if it's on my unit circle, 5 pi over 6 for the 150 degrees is both the angle and the arc. But if the radius changes, we need to use this formula. S is this arc, this intercepted arc. Theta, that's a Greek letter theta, we usually use that when we talk radians, is the angle. Now here's the catch with this formula. Theta has to be in radians, okay? It must be in radians in order for this to work, otherwise this formula is wrong. So as long as they give me a radian measure, and I know that because of the pi, I just take these two things and multiply. So 5 pi over 6 times 3, that gives me 15 pi over 6, which is a great answer. If I wanted to, I could round this out. It's roughly 7.85, and your label matches the radius. So since the radius is being measured in inches, my answer is also in inches. If they give you something that's not in radians, if they say I have a 270 degree angle with a 40-foot radius, this might be a field sprinkler. Okay, it's got a 40-foot radius, a 40-foot boom, and it goes 270 degrees. I cannot multiply these yet. I need to take 270 and I need to convert it into radians. So I'm going to take 270 multiplied by pi over 180, and I'm going to reduce that fraction as much as I can. Now, the nice thing about this one, it's on your unit circle. Okay, I already picked one that was on your unit circle, so now I can just plug this into the formula. So I've got 3 pi over 2, multiply it by 40. I know my answer is going to be in feet because that's the radius. Now, we're going to round this, of course. You've got 120 over 2 reduces to 60 times pi, which is roughly 188.50 feet. So that means the tip of my sprinkler boom out in my cornfield is going to travel 188.5 feet around that outside curve.